Welcome to the Chapter 5 review video. We're going to kick it off right here with some problems dealing with our mid-segment of a triangle. Remember, if you have a triangle and they've given you two midpoints, meaning you have congruent pieces on each of those segments, connecting those two midpoints gives you the mid-segment. And we know that there's this special thing about a mid-segment in that the mid-segment is always half the length of the entire base. So when I set up these equations, I'm going to want to say 2 times my midsegment. So like if I double that midsegment, I'll get the length of my entire base. Now I'm just going to go through. I'm going to distribute 2x plus 10 equals 3x minus 9. And then I'm just going to do some quick solving here. Subtracting my 2x on each side, 10 equals x minus 9. I'm going to bring it up here because I'm running out of space. 10 equals x minus 9. Add my 9 to each side, and I end up with x equals 19. Okay, for problem 2, I'm going to do the same thing. I see that I have my mid-segment because I've cut each of my two sides in half. I've connected them. So I'm going to set up my equation. 2 times x plus 5 will get me the length of my entire base. So I get 2x plus 10, because again I just distributed that 2, equals 3x. I'm going to subtract my 2x on each side, which gets me 10 equals x. Then we're going to move on down. Moving on down to number 3 and 4. Okay, so here I'm looking at something a little bit different. I see in 3 I have this angle. And the angle has this line going through it, which by these tick marks, I know is called my angle bisector. Now we learned a theorem which tells us that any point on the angle bisector of an angle, particularly this one right here for this problem, is going to be equidistant, meaning equal distance, from each of my two rays that make up that angle. So for this problem, all I have to do is simply set 6x plus 4 equal to 8x minus 6. Again, need to do some quick algebra. I'm going to move my x's. In that same step, I'm going to add my 6 just to save some space here. I get 6x gone, 10 equals 2x. And then if I divide by my 2, x equals 5. Now question number 4, again, it's something slightly different. I see that I have this line here, which has been cut into two congruent pieces. Cutting something into two congruent pieces is bisecting it, and because this is a segment, this is a segment bisector, this thing right here. Now, even more particularly, it's bisecting at 90 degrees, or a right angle, which means this line is perpendicular to this other line which has been bisected. So I have my perpendicular bisector. Now we learned a theorem which states that any point on my perpendicular bisector is going to be equidistant from the two endpoints of my original segment. So for instance up here they show you have a point and they tell you it is equidistant from your two endpoints. Well, they also gave me some expressions. So I have to use those expressions and set up 3x equals 5x minus 9. I'll move my x's. And I moved my 5 just because my 9's already by itself. So I do have negative x, but that's okay. Divide by negative 2. Ooh, that got a little curvy there. And I'm going to get x equals 9 halves. All right, so let's move our paper up just a little bit here. Okay, I'm looking at question number 5, and these directions do tell me that for 5 through 7, I'm going to be using the picture at the right, which is this figure right here. I've got a triangle going. We've got some segments, some angles going on here. Now, what I need to do is I need to make sure that I'm focusing in on only the information that they're asking me about. There's a lot going on in this picture, but I'm not interested in very much of it. In particular, for question number 5, I'm interested in segment AQ. I want to know, is it a perpendicular bisector or an altitude? Looking at AQ, I see this 90 degrees. That's why they're asking me if it's a perpendicular bisector and altitude, because those are the two segments that use a 90-degree angle. Okay, so I see that 90-degree angle, and I'm thinking perpendicular bisector or altitude. Well, now I just have to know the difference, right? I have this thing called a perpendicular bisector, which we actually saw right here, right? Perpendicular bisector. I bisected my angle, and I have a line going perpendicular. If I move down to this picture again, I see that I have a perpendicular, but did I bisect my side? No! So I can't have a perpendicular bisector. Okay, the other thing you can think of is I told you that an altitude will always go through an angle. This line is going through an angle. Okay, perpendicular bisector doesn't always have to do that. In fact, most times it won't. So I know that this is going to be an altitude. Okay, so looking at problem number 6, I'm focusing in on segment RB, and it wants me to tell them whether it is a median or an angle bisector. So looking at this, I see some really cool tick marks here. That means that I have two congruent angles. I've taken my original angle, ABC, and I have cut it into two congruent pieces, which is bisecting. So obviously, for this, I have an angle bisector. Now, let's look at what it would be if it was a median. Medians will always have a side being cut into two congruent pieces. So looking at 7, it says, what is segment CP? Well, I'm taking this side AB and I'm cutting it into two congruent pieces. Okay, now, I don't have a perpendicular here. So all I've done is I've found the midpoint, point P, and I've connected that to the angle across. That is a median. Okay, so we're moving on to the next set of 3 problems. They've given me this triangle, DEF. Whoa, there's a lot going on there. Okay, so I'm going to have to focus in again on exactly what I'm interested in. So question 8 says find MK and DK. That's here and here. Okay, first of all, M is the centroid. Very important. As soon as we see centroid, we should be thinking 2/3, okay? Or double. Both of those things are important because I know that this larger piece, DM, is going to be double the smaller piece here. So if DM is 8, then I know that MK is going to be half of that. MK is going to be 4. And then DK, I'm using my segment addition postulate. I know that 8 plus 4 is going to be 12. Okay, let's look at the next problem. They want me looking at LM, this piece here, and LE. And they tell me that EM is 6. So very, very similar to the last problem. If I know that EM is 6, this little piece here, LM, would have to be half of that, which is 3. And then by adding everything together, the 6 plus the 3, I get LE is 9. Now number 10 is a little bit different. Okay, it's asking me for an expression for FJ, but this should be fairly simple for you because FJ is this piece here, and they've actually told you what the bigger piece and what the smaller piece are. So all you have to do is take those two expressions and add them together. So FJ equals FM plus MJ. So I need to substitute in 2K plus 2Y. And that's your final answer. Okay, so we're going back to centroid. Check it out. In triangle, okay, B is the centroid. B is the centroid. But I have algebra going on, so I have to try to figure out what these lengths are using this algebra. All right, so like we were just saying in the last slide, I know that my bigger piece is always going to be double my smaller piece, which means if I take 2 of these smaller pieces here, it should equal this larger piece. Okay, so let's write that out. 2 of my smaller piece should equal my bigger piece. 6x equals 4x plus 8. I'm going to subtract my 4x. Sorry, that got kind of blended in there. I get 2x equals 8. Divided by 2 gives me x equals 4. And that's all that they asked me for. They wanted the value of x. So I'm going to do the same thing in my next problem here. My smaller piece is definitely this 5x. So 2 of my smaller pieces will get me my bigger piece. 10x equals 11x minus 7. Move my 11x. Because my 7's already by myself, this gets me a negative x, but that's okay. I know x equals 7. Going from negative x equals negative 7, if you think about it logically, negative x equals negative 7, so positive x should equal positive 7. The other way you can think about it is you just need to divide by negative 1 on each side, and that gets you positive values. Okay, question number 13. Explain where to find the orthocenter of a triangle. Orthocenter, oh my goodness, that's one of our vocabulary words, orthocenter. So immediately, I'm hoping that you are thinking, anybody in my ceiling, please bring cinnamon, apple, oatmeal. And then it's asking about orthocenter. Well, orthocenter is right here, and I know that orthocenter goes with altitude. So I can simply write the orthocenter is found at the intersection, section of the altitudes. Intersection, yeah, I can use that word, but another vocabulary word that we have is point of concurrency, right? So the orthocenter is the point of concurrency of each of my altitudes of the triangle. Let's move this page on up. Okay, so I've got a picture and I've got this word problem thing here. So let's read through. In triangle ABC, G is the midpoint of AB. G is the midpoint of AB. Okay, as soon as they say midpoint, I'm thinking I need to mark my picture up. So boom, boom, midpoint. H is the midpoint of BC. Boom, boom. And I is the midpoint of AC. Boom, boom. So I have all of these midpoints, and I know that in triangle, if I connect some of my midpoints together, I'll get my midsegments, which we have special relationships with. So let's connect all these midpoints together. What are the 3 pairs of parallel segments? Oh, so when we learned about midsegments, we learned 2 things. First of all, the length of my midsegment is going to be half the length of the base. The length of my midsegment is half the length of my base. Okay, but we also learned that your midsegment is parallel to your base. So for this problem, I have 3 sets of parallel segments. They are IH parallel to AB. And remember, we can use that cool parallel symbol so we don't have to write it a million times. IG parallel to CB. And my last one is GH, that's my vertical one, is parallel to AC. And then for the explanation, we just know that midsegments are always parallel to that base of your triangle. Okay, and then what kind of triangle is triangle IGH? So now they're asking me in particular for 15, what kind of triangle is this triangle right here? Well, I'm going to go back and I'm going to look at my original triangle that they gave me, ABC, because whatever ABC is, this triangle right in here is that same type of triangle, it's just a lot smaller. Okay, because of all of these congruent segments here, what this is called is a similar triangle. And we will actually learn a lot more about similar triangles. But okay, so 35 and 55 are two of my angle measures. Let's add those up and see what happens. 35 plus 55, that gets me 90, which means I must have a 90-degree angle right here at angle C. Okay, so if I take that, I know that's a right triangle, which tells me that IGH also has to be a right triangle. Your explanation could be something about the fact that it's similar to your original triangle ABC, which you determined is a right triangle. Now we're looking at 16 and 17. Are those our last two questions? Yes, they are. 16, I'm using this figure right here. Whoops. Try that again. I'm using this figure right here. It says, suppose EP is congruent to PG. How could you find the measure of angle PQG? Okay, so they said, suppose EP is congruent to PG. So what that shows me is that I've now created PQ being a midsegment of my triangle. And I know that my midsegment is parallel to my base. So I can put in those arrows telling me that they are parallel. And because they're parallel, oh, look at this. I'm going to extend my lines just a little bit. I'm going to extend those lines. And I see that I have a transversal here. If this angle is 85, then PQG must also be 35 degrees because I have corresponding angles. Okay, so because I have parallel lines cut by my parallel lines in red, my transversal in orange, I know that angle PQG, why did I write 35? Whoa. Hope you guys are still watching that. That is crazy. This should be 85. Because I have corresponding angles, meaning that these two angles are congruent. Okay, quick check. Holy cow. All right, so now the next thing I have is EF and PQ in number 17. I'm supposing that they have a slope of 2. What can you conclude? Oh boy, that is a very broad question. So if EF and PQ both have a slope of 2, well, I know that same slope means I have parallel lines. So we can kind of make all of these other assumptions we were just talking about with the two parallel lines and a transversal. And then also we know that those are, well, just because they have the same slope doesn't mean we have a midsegment. Yeah, so I just have parallel lines because I know my slope is the same, which means I can start looking into each of these angles. It's a very, very broad question. So if you have more questions about that, you can ask me in class and we can check to see whether you got something right out of it. But for now, we're going to move on to the next set of questions.